Right. We are in lecture 2 and today's topic is we need to learn regarding current and voltage. So you might have heard about the word current and voltage, but I think we don't have correct idea regarding that one. So we'll try to understand what is meant by current and what is meant by voltage. So before learning regarding voltage, we need to learn about grade 9 topic. What is that grade 9 topic? In force and laws of motion chapter we have learned. If you take an object, some object which has some mass m, okay, we don't want, this object will be at rest. This object will be at rest first of all. Now we need to make that body to be in motion. So I need to make this rest body in motion. What should I do? ఒక బాడీ రెస్ట్లో ఉంది, దాని మోషన్లోకి సెట్ చేయాలి. ఏం చేయాలి? నేను ఫోర్స్ అప్లై చేయాలి. సో వీ నీడ్ టు అప్లై ఫోర్స్ ఆన్ ది బాడీ. ఆర్ యూ క్లియర్ విత్ దిస్? ఇఫ్ యూ అప్లై ఫోర్స్ ఆన్ బాడీ విచ్ ఈస్ అట్ రెస్ట్, దట్ బాడీ విల్ బీ ఇన్ మోషన్. రైట్. నౌ we have one formula in physics class 9. Work is equal to W is equal to F into S, force into displacement. Work is equal to force into displacement. What is the meaning of this? In the sense, if you apply force, this body, let us consider it is at A. Body is at A. As soon as applying force on this body, that body will move, right? And it will come to this position, na? Means at least it will move to B, right? So from A to B there is some displacement, na? From A to B there is some displacement. Means you are applying force and body is displaced, then work is said to be done. Work is equal to formula force into displacement. What is the meaning for that? When force is applied, body is displaced, then work is said to be done. Now you see, let us take one conductor. Conductor in the sense any metal wire, any metallic wire, maybe copper, aluminium, zinc, iron, etc. Any copper wire you take, that is conductor. What is meant by conductor?
Any copper
which allows electricity. In yesterday's class we have discussed it. Conductor in the sense, conductor is a material which allows electricity. All metals are conductors. Now let us take, this is conductor. In conductor there are atoms, right? If it is iron conductor, iron atoms will be there. Copper conductor, copper atoms will be there. Like that atoms will be. At the same time, in conductor there are free electrons, kada? Yesterday we have discussed. Free electrons are responsible of flow of electricity in the conductor. If there are no free electrons, no electricity. So these red dots known as free electrons. Are you clear with this? This is conductor. These are atoms. You see, this is conductor. These are atoms, and these red dots are free electrons. Fine. Now, you see, let us consider let us take one small circuit. Consider we have one small bulb, and we take one small cell. If you take cell here, you can find cell with small cap on it, which is positive terminal, and this is flat, right? This flat side is negative terminal. For a cell there will be two terminals, positive and negative. This flat side is negative and this button you can find, that is positive. Now here you can find this is positive, this flat is negative. Now we will take two wires, metallic wire, maybe copper wire or aluminum wire or iron wire. We will take this wire and we will attach one wire to positive terminal of the cell, another wire from the bulb to negative terminal of the cell. Then automatically bulb glows, right? Automatically bulb glows. Why bulb glows? Why it will glow ante, it is quite simple. You see, this is wire, metallic wire na. This is metallic wire, right? And in metallic wire what will be present? Free electrons. See here, free electrons. Now let us consider we have free electrons here, maybe here like this. Consider this free electron name is A. Here we have one free electron. We have given a name for the free electron as A. Okay. Now this is the cell. Basically what is the work of the cell? We need to understand. If you take cell, this is dry cell which has positive terminal and negative terminal, and try to understand this one. Now you can easily understand why there is current, why there is voltage. This is positive terminal with positive rod which is made up of carbon, positive rod made up of carbon, and this negative can made up of zinc. This is carbon and negative rod made up of zinc. This cell is known as dry cell. Why? Because chemicals will be present inside this cell in dry state. Leak proof, some cells you can find, it is like a leak proof, something they will be giving, right? Okay, here you can see, here also they have given leak proof, NIPO, something. Huh? Okay, inside there will be chemicals. Now I don't want to go into deep. In cell there will be chemical reaction. Basically they will ask you what is meant by cell. Cell is a device which converts chemical energy to electrical energy. In simple sentence, cell is a device which converts chemical energy to electrical energy, right? Now in this dry cell there will be chemicals na, and you see this is negative terminal. This is negative terminal. Near this negative terminal, lot of electrons are generated. Lot of free electrons will be present. Try to understand this. Near negative terminal, there will be lot of electrons. What is this terminal? Negative. What are these? Free electrons. Now, in 6th class we have studied one thing. Negative charges always it will be trying to move towards positive terminal. Negative charges always it will be trying to move positive terminal. And positive charges always it will be trying to move towards negative terminal. I mean oppositely. Like charges repel, unlike charges attract. Did you hear that? Right. Same thing will happen. Now you see these are electrons na, and electrons will be trying to move towards the positive. Electrons eppudu kuda positive terminal దగ్గరికి వెళ్ళాలని ట్రై చేస్తూ ఉంటుంది. Now you see inside this is positive terminal, right? This is positive terminal, right? Now we can tell, sir, here we have a lot of free electrons na. All these free electrons straight away it will go and touch this terminal na. All free electrons which are present inside the cell, directly it will go and touch the positive terminal na. Like that we can get doubt. But here what is happening in the sense? There will be no internal connection. There is no internal connection between positive and negative. There is no internal connection between positive and negative. Ante here for this positive rod there will be one cardboard or maybe some polythene sheet or something they will be arranging such that electrons straight away it cannot go and touch this positive terminal. There will be one obstacle, oka addu untundi, and that positive is wrapped such that electrons straight away it will go and touch, it cannot go and touch. Appudu em chestundi ante, you see all these free electrons are very eager. All free electrons are very eager to go and touch the positive. You see now here this is cell, right? Here we have many negative charges na, many free electrons na, but there is no connection between positive and negative internally na. Then what will happen in the sense, we have arranged one wire here, we have arranged one wire, and this wire will act as shortcut. Wire acts as shortcut, and all these electrons it will come out. You see this is the electron from the cell, it will come out, and that electron will flow in the conductor and it will reach the bulb. This electron will come out, this electron will come out, like that all electrons will come out, and all these electrons will be in motion. All these electrons will be in motion, and those electrons will go and touch the bulb. When electrons are entering into the bulb, bulb glows. Are you getting the point? So here flow of electrons we have studied, na? Flow of electrons. Flow of electrons is nothing but current. So if they ask you what is meant by current, you can tell this definition: flow of electrons. What is the charge of electron? Negative. What is the charge of electron? Negative. So this definition can be said as flow of negative charges, right? Flow of negative charges. So what is meant by current, guys? Flow of electrons. What is the charge of electron? Negative. So what we can tell? Flow of negative charges. Now you see, current is represented with letter I. Though it is starting with C, it is represented with letter I. Now consider this is conductor. Let us take one area, cross-sectional area. I mean simply to say any one point. Here we have a point. Let us consider this is the point. Let us consider there are few free electrons here. Few free electrons here. You see, when this conductor is attached to cell, when that conductor is attached to cell, automatically this cell is doing some work. Guys, here you see this one, this formula. Try to understand. Work is equal to force into displacement, na? Now this cell is doing some work. What work it is doing? It is producing force. What is the work of cell? It will produce force. Here you need to observe. What is the work of cell? It will produce force. Force on what? Force on electrons. Cell is doing some work. What work it is doing? It is applying force on electrons. If force is applied on electrons, those electrons will be in motion. Try to understand this. Cell is doing some work. Work is nothing but applying force on electrons. When force is applied on electron, you see, consider this is one electron. That is one electron. If a force is applied on electron which was at rest, now it will be in motion. Motion in the sense flow only, right? Flow of what? Electron. Flow of electron nothing but what? Current. So whenever cell is attached in a circuit, cell is used in a circuit, it is maintaining some current. Current is produced, Now they will ask you the definition and formula of the current. We will try to understand that. So once again, let us try to understand. In circuit, we will use cell. Cell is doing some work. What work it is doing? It is applying force on electrons. Now electrons, first it was at rest. Now those all electrons will be in motion. If electrons are in motion, we are calling it as flow of electrons. Flow of electrons is nothing but current. Flow of electrons is nothing but current. Now, you see, current is represented with the letter I. Now consider this is one conductor where we are considering this is the point, just a reference point. Any point you can consider. This is one reference point and we can call that one as cross-sectional area. Cross-sectional area. Why? Because metallic wires will be in form of cylinders only. Now, if you cut the metallic wire and if you observe, it will be like cylinder, right? So this is cross-sectional area. Now, consider there are few free electrons here. A few free electrons. As soon as attaching this metallic wire or conductor to a cell, this is symbol of cell that we are going to discuss in next lecture. If we attach to a cell, automatically this cell is doing some work. It should apply force on electrons such that electrons which were at rest, now it will be in motion. Now these electrons will be in motion, na? Is it so? All electrons will be in motion. Now all electrons will flow. Now the question, how many electrons are flowing in 1 second? If you can calculate, that is nothing but current. So simply to say, current is nothing but net charge. Net charge. Net charge in the sense number of electrons flowing in unit time. Unit time means in 1 second. That also we will discuss. Current is equal to formula net charge by time. And current is represented with the letter I is equal to net charge is represented with the letter capital Q. So capital Q is nothing but net charge means number of electrons. This is important one. Write this formula. Q is equal to N into E. Q stands for net charge. N stands for number. E stands for electrons. Net charge is equal to number of electrons. Q is equal to N into E. Upon time is represented with the letter T. I is equal to Q by T. I is equal to Q by T. I stands for what? Current. Q stands for net charge. T stands for time. Now, all these are measurable quantities, guys. All these are measurable quantities, means we can measure current, we can calculate number of charges, we can measure time, so that all these measurable quantities will have SI unit. All these three have SI unit. SI unit of current is ampere, represented with a capital A. Scientist name ampere is equal to charge. SI unit of charge is coulomb, capital C, coulomb, divided by time. SI unit is second. Means what is the meaning? 1 ampere is equal to 1 coulomb by 1 second. So whenever you want to say 1 ampere of current, internal meaning of that 1 ampere of current is 1 coulomb of charge. 1 coulomb of charge is 1 coulomb of charge is flowing in 1 second. 1 coulomb of charge is flowing in 1 second. Okay. Now ikkada what is meant by coulomb? Group of electrons. Group of electrons or some bunch of electrons. Group of electrons or bunch of electrons. That we'll see what is 1 coulomb, everything in next class. Okay. Now current I is equal to Q by T. This is the formula you need to remember. This is the formula and these are SI units. I said current is measurable quantity, right? We can measure current. Current can be measured by using a device called ammeter. Ammeter is the device which always should be connected in series in circuit. Ammeter always we need to connect in series in circuit. There is a symbol for ammeter. There should be a circle with a letter A and these are connecting wires. This is the symbol of ammeter. Yeah, we are done with current. Next concept is voltage. You see, I said in circuit if you connect cell it will do some work, right? It will do some work. What work it is doing? It is applying force on electrons. If you apply force on electron, automatically all electrons will be in motion kada. Now you see, consider this is conductor where we have few free electrons at A. Now I need to make all these free electrons to move from A to B. A to B I need to move all those free electrons. Now what I will do, if I take that conductor and if I throw it down or if I do something, I cannot move it. I need to connect this metallic wire to a cell, right? If you connect cell in the circuit, then only work you can observe. Without connecting cell, you cannot observe any work. Na? Now, you have connected cell. Now automatically all these free electrons will move from point A to point B, right? Means you are doing some work on free electrons. Free electrons nothing but charges only, na? How many free electrons we don't know, that we can take it as N into E, na? Number of electrons. Number of electrons is nothing but what? Q, net charge. You are applying work on net charge. So simply to say you are doing some work on net charge, which is nothing but voltage. So voltage is nothing but amount of work done to bring charges from one point to another point. Amount of work done on charges to bring number of charges from one point to another point. To bring charges from one place to another place, one point to another point, one side to another side, we need to apply voltage. If there is voltage only, there will be work. If there is work, you can observe movement of charges. If there is no voltage, there is no work. And voltage is represented with letter V is equal to work is represented with letter W upon net charge is represented with letter Q. V is equal to W by Q. So what is this? V stands for? V for voltage, W for work, Q for net charge. And all these are measurable quantities only now. We can measure voltage, we can measure work, we can measure charge. So that all these are measurable quantities, physical quantities. For all physical quantity, for every physical quantity there will be SI unit, guys. For every physical quantity there will be SI unit. Okay. Now SI unit for voltage is volt. Volt. That is scientist name Alessandra Volta. So SI unit of voltage is volt is equal to SI unit of work in 9th class we have discussed, that is joule. SI unit of charge in current concept we have discussed, that is coulomb. Okay. Now they will ask you what is meant by 1 volt. 1 volt is nothing but 1 joule of work. 1 joule of work is done to move 1 coulomb of charges from one point to another point. So what is meant by 1 volt? 1 joule of work is done to move 1 coulomb of charges from one point to another point. Here, if you are applying 1 joule of work, if there are 1 coulomb of charges, all these charges will move. Okay, that is nothing but 1 volt. So battery is giving 1 volt of charge. That is the meaning. And I said voltage also we can measure. Voltage can be measured by using a device, voltmeter. Voltmeter. And always voltmeter should be connected in parallel. Voltmeter in parallel. And symbol of voltmeter as ammeter, there will be a circle. Ammeter we have represented with A. Voltmeter with V. These are connecting wires. Clear? Right. In next lecture we are going to see once again what are the formulas we have discussed here, and what is current, what is voltage, let us revise, and then we will see symbols, because every time I cannot draw bulb, in the sense I cannot draw bulb like this with filament or fuse, and cell in the sense I cannot draw every time like that. And also we are going to discuss direction of electrons and direction of currents in next lecture. So that's it in this lecture.